Thank you, everyone. I'm going to do a brief talk about structural topsides inspection. Now, for those of you who may or may not know, it might be a bit controversial in saying this, but topsides inspection of structures is a relatively straightforward process. But the implications for it are horrendous, potentially. You look at that picture there, the left-hand side, typical North Sea platform. It's a fairly busy looking one. That happens to be shearwater. Structural components make up a huge proportion of that platform. If it's not mechanized, if it's not energized, and it's not pressurized, it's structural. And typically, structural components will make up between 40 and 60% of the overall weight of a platform. So it's a significant item. How we do those inspections? Well, typically, we use inspection techs to go out there. We will do general visual inspections. We'll do close visual inspections. If we need to look at a bit more detail, we'll use UT techniques to see how the structures are behaving. If we need to get to those hard to get to areas, we use the rope access teams. And again, as has been coming out in the industry over the last few years, we're now starting to use drones more and more. At the moment, they're a bit limited because they'll be limited to more like general visual and close visual inspections. But who's to say that technology won't move forward and we'll be able to use them for doing more detailed inspections in the future? Observations from the past about how we've done structural inspections. Typically, they've been planned. They evolve in a cycle. We might do an inspection in a component every 3 years, every 5 years, every 10 years perhaps. Whether or not it's in good condition or it's not in good condition, it's the typical cyclic inspections. Inspections can be subjective as well. The chart on the right-hand side, some of you might be familiar with it. It's an RE scale for measuring coating breakdown. And it ranges from 0% up to 70, 80, 90%. But that's a subjective assessment. No two people will say the same thing. So when you get an inspection report, it's somebody's opinion a lot of the time. Rather than having hard data, it's an opinion. The report content, quite often, again, as I mentioned, it's opinion as opposed to hard facts in a lot of these cases. And one of the other flaws about previous inspections in the past, there's a lack of follow-up. You get an inspection report, it highlights we have an anomaly here or anomaly there, there's a bit of coating breakdown here. So what? What do you do about it? Well, we'll leave it till the next time. We'll inspect it again in 4 or 5 years' time. So there's a definite flaw in the lack of follow-up. An example of that is this component here. This is part of a walkway in a drilling module. It was inspected several years ago. And the inspection report said, okay, it's got a coating breakdown scale RE7, which means it's fairly significant. It's at the point of affecting the actual structural steelwork underneath. And it's got a corrosion category of 3. Okay, what do we do now? Well, we'll just wait for the next inspection. And I'll come back to that picture later on, because it's quite interesting. So, why is that often the case? Well, I say inspector qualification. What I mean by that is that typically inspectors are not structural inspectors. They come from a pressure systems background, or they come from a piping or a mechanical background. We don't have structural inspectors per se. We talk about constraints. With structural steelwork, it's all right to hit it with a hammer. If you've got a bit of corrosion and a bit of steelwork, it's okay to hit it. But the perception is it's going to weaken the structure by doing that. And that's typically from people that have come from a pressure systems background. You don't sit and hammer away a live pipeline. Nobody would. And the other thing is this piping versus structural. The way that a structural item is affected by integrity is different from a piping system or a pressure system. There's far more threats on a pressure system than there is on a structural item. It's quite straightforward, it's quite simple, he says. Right, when I talk about the main threat to structural, it's corrosion. In at least 90% of any topsides element, the main threat to the integrity of that item is through corrosion. Corrosion doesn't give you any strength benefits. It weakens the structure. And the other thing about corrosion is it masks what's really going on underneath. And I'll show you some examples of that in a second. And it's unpredictable as well. No two areas behave the same. A good example of that is exhaust ducts, for example. They tend to corrode a lot quicker than, say, a general module structure, steelwork would, because the environment that they're within is far harsher. So you can't always predict how things are going to behave. So go back to that picture I showed you earlier on. That was taken in 2010 and was subject to a general visual inspection. In 2017, that same item was given a close visual inspection, and I mentioned earlier on about knocking off the corrosion product. That's what they found underneath. Virtually no steel. That was supporting a major walkway, and it instigated an immediate repair. They closed down that walkway, which had safety implications as well, until that repair was carried out. And it involved getting a lot of scaffold out, getting a major engineering repair instigated before they could put that walkway back into service. Another example is this column here. Looks a bit dirty, coating's a bit sort of corroded, if you want to say. That was inspected in 2011. Again, it was a fairly general inspection that was done. 2017, look what you've got now. And that was only found by doing the same thing again, getting the hammer out and actually hitting away at the corrosion product to see what was underneath. And that was immediately condemned. Again, rapid intervention was required. But it doesn't need to be that way. I thought I'd put up a couple of examples for you, let you have a look and see for yourselves how subjective corrosion is when we talk about structures. Our good friends, the handrail stanchions, the one on the left and the one on the right. Two varying degrees of scale corrosion on them. Which do you think is actually the worst of the two? Would you say it's the one on the left or the one on the right?
Right-hand side.
Right-hand side. Yeah, you've seen that slide before. I'll see you later, Stuart. If I looked at that first of all, I would have said the one on the left, because it looks as if there's more blistering and more scaling on it. But in fact, once you knock it all off, it's there's more steel product left on it than there was on the one on the right. Example, good friends, handrail socket. We've got two fairly well corroded handrail sockets. Again, I'll ask the question, which one do you think is worst? How can you tell which one's worst? The one on the left. And you only find that out by knocking off that corrosion product. So we've been looking at how we can improve our overall inspection and our integrity management when it comes to topside structures. One good thing is, I mentioned earlier on about the background of the majority of the techs that go out and do the inspections for us are not structural. So engagement. The integrity engineers sit down with the inspectors before they go offshore, run through the job. It's like a toolbox talk on shore. Highlight the areas you want to look at, highlight how you want them to be looked at, and tell them exactly what it is you're looking for at the end of the day, when that report comes back. Retention is a good thing. We'll talk about inspectors that have got a long case history of working on the same asset. Once they build up that knowledge, that's invaluable. Knowledge is power. They've got the case histories, they know how the platform's behaving, they know the way that the failure mechanisms are going to occur. They've got the knowledge, and it's well worth holding on to. Bane of my life is work packs. I sometimes think there's far too much information in a work pack that goes offshore. There's no reason at all why we can't streamline them. Keep them to the facts. Simple, straightforward facts. Remove the subjectiveness from our assessments. We need to make sure that what we're looking at is the right information. There's no good saying, well, I think it's a bit this and it's a bit that, and it'll be okay for a couple of years. We need to do away with that. We need to get the hard evidence, the hard facts. How is that structure behaving? And the only way you're going to do that is to delve deep into the physical inspection of it. So what does this mean to the operators at the end of the day? Well, I like to say costs, and it's also going to improve safety. We're talking about having timely defect detection, right? Those examples that I showed you earlier on, they could have been picked up a lot sooner than they actually were. And they could have been worked on with a simpler solution, maybe an FM campaign, instead of closing off areas of the plant and coming in with heavy engineered repairs. Very, very costly. It helps to reduce your inspection. If you know how your items are behaving over the course of time, you can sit there, you can push out your inspection frequencies. You don't have to do it on a cyclic basis. Just because Maximo or SAP says you've got to do it every 3 or 4 years. If the structure's fine, why do you need to keep re-inspecting so often? Push the boundaries back. And appropriate assessments and interventions at the right time. It's horses for courses. You don't use a sledgehammer to crack a nut. If an FM campaign, a bit of touch-up and paintwork is all that's required, then that's all you need to do. I'll leave you with a couple of examples of what we call intervention. This item here is a flare boom that sat undetected for a number of years. When it was inspected, they came across that. So immediately, major engineering reassessment done, major repair solution put forward, RAT teams sent out, all sorts, cost an absolute fortune. The reason they did that, because that platform is still going to be operating for quite a number of years. It's horses for courses. If that was coming towards the end of its field life, probably wouldn't have done anything like that. It might have been okay to leave it at that. You would still have had to do an engineering assessment to say it was safe enough to carry on into your decommissioning phase. And this last example, again, this deck, it's blistering, it's starting to go, but there's another example of an asset that was moving on into late life and was going to be carrying on for a number of years production. FM campaign, tidy it up, clean it up, and you've got a nice clean deck sitting there, and it will stay that way for a number of years. So again, you've reduced your inspection requirements because you've got this nice little deck. So there you go, that's my little presentation for you.